Hello, this is the introductory video to the Voter Cloud application. The team members were Raul Garay and Elder Feldbein, and our mentor was Gus Monje as well as our product owner, and our instructor was Masood Sajjadi. Public engagement in local government is notoriously low. Voter turnout for local elections across the country are at the lowest they have been in decades. The lack of engagement that exists leads to an uninformed or misinformed public with elected officials that are not representative of their community and their views. As a result, laws passed by these officials may not be in the best interest of the public. On the other hand, citizens who are willing to engage may not know how or where to find the information and resources they need. Information for elections, current officials, policies, and what the thoughts of those around them can be difficult and time-consuming to find. Citizens currently get their information from newspapers or internet searches. Flyers and signs are distributed around respective election zones. Commercials are another form of communication that can provide more information to citizens, but a candidate or an interest group pays for them. Public meetings are often held to discuss issues that affect the politician's zone. These meetings and hearings tend to produce a low public turnout. If a citizen wants to get involved, they will need to attend these meetings, write, email, or call their politicians. These meetings are open to the public so that the politicians can gauge public opinion. Politicians have also taken to social media outlets to interact with their community. This is a Gantt chart of our sprints. As you can see, we completed every story throughout all the sprints. This takes into account all the way from the beginning of the semester to the end. We completed many user stories throughout the entire semester. However, you see here, many of the features and user stories are the primary concern for our working application that you can see on the front end, or the primary features that provide the functionality for the application. They include the side menu, view local politicians, search by location, elections, representative image profile, polls, petitions, signature, the database security, PDF generator and serving, chat locality, representative chat, the admin portal, design, and testing. Our use case diagram concerns itself with two actors, the user and the admin. The admin is actually a type of user, and only the admin has access to the make poll user story. Of all the sequence diagrams in our project, we chose 4 important ones. This first one, the create poll, is from the admin user point of view. It starts off at the admin portal, and once the admin enters the information into the create poll section, submits the request, it goes into the server where it's picked up by the poll controller. Here, the poll controller takes advantage of the methods to insert into the database, where we see insert poll, and it goes ahead to notify Meteor that a poll has been, that the database has been updated. Once it recognizes that the database has been updated, the Meteor reactivity controller, which pushes real-time changes to all clients, will do so by notifying a change to the Meteor reactivity controller inside each client. Once so, it'll enter the poll into the Mini Mongo database in each client, and once it does so, we see that all the changes have gone through every single part of the system and all the way to the end client, where the client will be able to see the changes made. This sequence diagram is of the politician image. It is from the user point of view. So when the user requests a politician, the image that is returned is either from the Google Civic API source, Twitter API, Facebook API, or the Wikipedia. So when the user goes ahead and types in their address, they will go ahead and an algorithm will start. So this algorithm will iterate through each of the sources. If first the Google Civic API does not have the image for that particular representative, then it'll go next to the Twitter. If the Twitter doesn't have it, it will then go to the Facebook API, and so forth all the way up until the Wikipedia. Voter Cloud is actually designed using an MVC model, which is the Model View Controller, and the model is represented by the MongoDB database, which comes with the Meteor packages. Within, for the view, is our HTML and CSS files, which include the surveys, the polls, and the Meteor templates. And for our controller are our JavaScript files. Our hardware and software mapping contains three parts. At the center is the server. The server contains the Mongo database that actually has the entire database of the Voter Cloud application. Within there, it has a copy of the Meteor application so that it can process the server JavaScript files, which is the back end of the application. Now, the other part is the mobile device client. This is what the user sees. It has a mini Mongo database which acts as only what the user is supposed to see and gets that information from the server. It contains all the JavaScript files, the HTML, and the CSS files that the user needs in order to run the application. The final part is the browser client, which contains the admin portal. It is almost the exact same thing as the mobile device application. However, the only difference is that it includes the admin portal piece, which is to create polls. Our persistent storage, again, is of the Mongo database type. Mongo database is not a relational database. Instead, it is optimized for big data. Here at the top package, we see the server-side MongoDB. We see that it contains every single collection in the entire Voter Cloud application. On the bottom half, the Voter Cloud client mini Mongo contains only a partial of what is in the server side. It is missing the support as well as several other fields, as in the users collection. Voter Cloud security and privacy consists of a login and registration system. The login is the first thing you see when you first open up the application if you're not already logged in. As you can see on here on the left hand screen, it should ask you for your email and for a password. If you don't have one, you would register and it will take you to the screen on the right, in which you would enter those credentials and then finally register. There were three primary design patterns that were used throughout our Voter Cloud application. The first is a singleton. It was used primarily for their database objects and to limit them to a single instance. This allowed for a lot of security throughout the application. The second one is the command. It is primarily used for UI creation and for Meteor templates. This allows us reusability for a lot of the code. The final one is the abstract factory. It was primarily used for the chat versions of the application. Each chat has the same interface. The only difference are the actual content within the chat as well as the metadata, which includes the location of where the chat is being represented from, or which politician the chat belongs to. One of the primary algorithms in our application is to grab the information from the representative when we're searching for a representative. It first divides the representatives into divisions, and it places them into an array. Within each of those indices in that array, there's an official index, which is called the office. Within that office, it has an official indices array, which gives you all the information about that politician, including the address, the channels, name, party, phone numbers, photo URL, and any other URLs associated with that politician. Here's an example of a sunny day test case that we use for a representative chat. Here we can see that the test objective is to test that the representative page in terms of redirecting and chat participation works, and checking that the chat for each representative is functional. The precondition is that the representative list is already loaded, the longitude and latitude coordinates are enabled, and that there are representatives in that area. First, we click on the menu button to see the menu. We go to the representative page. we search by the GPS just to grab the list of all representatives within that area, and we click that the desired representative. Once we're in the representative page, we go and we attempt to add a comment to that chat. The text data used was hello representative, and we expect that the message was added onto the list and that we could view it on the page immediately, and so could others. The actual output was what we expected. Finally, this is a list of rainy day test cases that we had on our application. This is for the mobile application version, in which we took the application, deployed it into a package app on an Android phone. Here we see that we're testing several use cases that were previously completed. We tested on both Wi-Fi and 4G LTE. Here we see that there were several that did not work. Mostly in chat locality, the maps did not load, and everywhere else we see that whenever there was a photo that needed to be displayed, it did not, including the representative chat, the petition, the chat room, and the local politicians. This worked this exact same way for both Wi-Fi and 4G LTE, which showed us that it was not an issue due to the network. For our automated testing, we want to show you the search for representative by GPS location use case. Here we see the Java code, and it'll open up the page. Once it loads, you log in, it opens up the menu, it goes to the representatives page, it searches by GPS, and it finally shows a successful test case. This concludes the VodaCloud introductory video. Thank you for watching.